Hold on. These problems are about kind of understanding how the unit circle works. If you were asked to do this without your unit circle on you, we are going to use the triangles and we're going to verify our answers on the unit circle. But what I want to do here is I want to get more in-depth familiar with how the unit circle works through our warm-ups. So I'm going to use a pen and a straight edge, and that's it. So if you have that stuff, that'd be great. And we're gonna do number 1 through 3. Yeah. Okay. So first thing I do on any of these problems is I label the x-axis. This is 0, 3 pi over 3, and 6 pi over 3. 0, 3 pi over 3, and 6 pi over 3. Does that make sense to you guys? So 0, that reduces to pi, and that reduces to 2 pi. And you work with whatever the denominator is in that particular problem. Okay, next question. Does it make sense to you guys that the angle they gave us, 5 pi over 3, would be located on the bottom half of the circle? Okay, so what I'm going to do is I'm going to use my straight edge to kind of eyeball breaking up the bottom half of the circle into thirds. And this is the first time you're doing this, so it will seem more difficult. Once we do a bunch of these, it will be easier. So I want you to notice I have 1/3, 1/3, and 1/3. You guys see where my thirds came from? So it's just like a piece of, just like a cake or something. I just split the bottom half into 3 equal pieces. Okay, and this helps me visualize. So that's 3 pi over 3. This would be 4 pi over 3. So this spot would be 5 pi over 3. The directions on these warm-ups say draw the terminal side and label the angle on the circle. That's what I just did. Drawing the terminal side is the arrow, and then labeling the angle on the circle is putting the 5 pi over 3 right there. So I'm done with step 1. Step 2, find the reference angle and draw the appropriate special triangle. Okay, so I'm in quadrant 4. The reference angle is going to be the difference between these two. So up here, I'm going to say 6 pi over 3 minus 5 pi over 3 equals 1 pi over 3. But I need to figure out which special right triangle that is. And it's kind of obvious to me, maybe not to everyone. I'm going to use my conversion technique, and we're not going to have to do this every time. We're going to get the hang of it. These will go faster as we go. The pi's cancel, and 180 divided by 3 is 60. Okay, so what was the point of that? The point of that was for us to know that we need to use our 30, 60, 90 triangle. You guys remember pasting on the 30, 60, 90 triangle on the bottom of your unit circle. Okay, now make the triangle. Made that ugly. Okay, I labeled my reference angle in there. And what I'm going to do now is I'm going to grab my unit circle and look at the sides of the 30, 60, 90 and figure out how to label my triangle. So the hypotenuse is 1. The short side is 1/2. And the long side is √3/2. However, I have to be really careful because I'm in the fourth quadrant. If I'm in the fourth quadrant, what are the signs of those things? Yeah, so if you're looking at the fourth quadrant, X is positive, Y is negative. So I need to put a negative in front of my √3/2. Label the sides of the special triangle, blah, blah, blah. Remember to incorporate the sign and then write the coordinates of the terminal side. The coordinate at 5π/3 is over 1/2 and down √3/2. And you're sitting there thinking to yourself, Mrs. Tabit, we did the unit circle the other day. I could have gotten that information for you in about 4.2 seconds from my green page because it's right here. 5π/3 is this coordinate. I understand that. I really want you guys to understand how the unit circle is made and what's happening here though, and to be able to recreate these without memorizing the unit circle. So that's why we're doing these. Okay. Number 2. Angle is 3π/4. 0, 4π/4, 8π/4. Does it make sense to you that the angle 3π/4 will be in the top half of the circle? Okay, so I'm going to cut the top half of the circle into 4 equal pieces. So I'm just going to cut each of the quadrants down the middle. It's not perfect, but it's okay. And then I count to myself 0, 1π/4, 2π/4, 3π/4 would be right there. Okay. Reference angle is in between 3π/4 and 4π/4. So 4π/4 minus 3π/4 is 1π/4. That is 45 degrees. Why does it make sense that it would be 45 degrees without me doing all of that work? Yeah, exactly. I cut the 90s in half, so you can reason out that it's 45. We will not continue to do that math once we start to get the hang of it. We're just doing it for now. Okay. Gonna draw my triangle in. So which triangle do I need then? Beautiful. 45, 45, 90. Okay, which is this guy here. My hypotenuse is 1. The legs are both √2/2. And then I have to stop and think about the sign of those, like not the SIN sign, but the SIGN sign. X is negative, Y is positive, so I need to go back and put a negative on that one. And then the coordinate is back √2/2, up √2/2. Does that jive with the coordinate on your unit circle that you could have gotten in 10 seconds? Right there? Yep. Okay, last one for the day. 2 pi over 3, 0, 3 pi over 3, 6 pi over 3. Okay, now I'm going to ask you a question. 2 pi over 3, is it located in the top half or the bottom half? Top half. And what should I cut my top half into? Thirds. So that would be 1 pi over 3, 2 pi over 3, 3 pi over 3. Okay, now we don't need to do all the math here again. What's the reference angle? Okay, I prefer my answer in radians, but yes, pi over 3. And now I'm going to ask you, what special right triangle do I use if the reference angle is pi over 3? 30, 60, 90, great. Okay, so I go, here's my 30, 60, 90. The hypotenuse is 1. The short side is 1/2. And the long side is √3 over 2. And that's why I try to draw it to scale, because it's easier to tell what the long side and short side are. Okay, what about the signs of these, the positives and negatives on quadrant 2? Beautiful. Negative x, positive y. So that means my coordinate is back 1/2 up √3 over 2. Just verify. Back 1/2 up √3 over 2. Okay, when you guys are set, I need you to find the resource page that says 9-84 at the top. And then I need you to go back into your notebook and find problem 9-37. It's old one, 9-37. Okay, it doesn't say 9-84 at the top. It says 9.1.7 resource page. Sorry. Yeah, it is number 84. It just doesn't say that. Let me find it for you so you can see what it looks like. This one. Today we're going to work on tangent. It's pretty much the only day that we work on tangent. I like it. It will come back in your Pythagorean identity problems, but I'm never going to ask you to graph tangent in math 3. It's a weird graph. We're going to graph it today just for funsies, but I'm never going to have that on a test or quiz. If pre-calc, you'll definitely graph tangent, but not in math 3. We just want to give you an idea of what it looks like. Okay, but we're not going to start with the resource page. We're actually going to go back to number 37 in the notebook, which looks like this. And if you have some space up at the top, hopefully you've got a little bit of space up there. We're going to look at tangent. Okay, so here, let me ask you a question, guys. Oh, the only thing you need to add right now is the red bit, the like pink part. The rest of it should be there. What does TOA stand for when you're talking about tangent? What's TOA? Opposite over adjacent. Okay. So if I'm working on this triangle right here, which is teeny tiny, and I'm going to zoom in a lot so you can see him. if I'm looking at the 34-degree angle here, does it make sense to you guys that the opposite is y and the adjacent is x? Let me say that again. If I'm working with this 34-degree angle here, does it make sense to you that the opposite is y and the adjacent is x? Okay, so to find tangent of 34 degrees without a calculator, just working on what we know from this page, we know that opposite over adjacent in this case is y over x. Okay, and what is y in our trig functions? Which one is y? Sine, yep. And which one is cosine? Which one is x is cosine? I answered my own question. Okay, so what we're going to do to find tangent is we're going to take our decimals from y and x from this problem and divide them. So sine was 0.559 and cosine was 0.829. 0.559 divided by 0.829 is 0.675. Okay, now I'm going to, you guys don't need to do this. I'm going to put my calculator back in degree mode. And find the tangent of 34 degrees. And hopefully I got 0.675. Okay. So now I want you guys to scroll down to number 39, where I told you to leave a little bit of room here for tangent. So up here, you should just have 0.675. Tangent gives you the slope of the triangle. I don't know if you guys remember in math 2, you started with tangent because you found the slope. And y over x, that should say and, not any. I don't know. I was starting to write the y from the y over x already, apparently. And y over x or sine theta over cosine theta. Okay, so that's it for the notebook. It's not a big deal. I just want you to have all three there together. Okay, so now we're going to go back to that resource page with what we know. And just remember, I'm just getting this from opposite over adjacent. It's not a big deal. What we're going to do is we're going to use our unit circle to get these values. So I'm going to scooch my unit circle over. Cosine is x, sine is y. So the coordinate at 0 radians is 1, 0. Are you guys with me so far? Does that make sense? Okay. The coordinate at pi over 6 radians is root 3 over 2 comma 1/2. Just kind of going around the circle here. I'm basically just copying these things straight from my unit circle. I'm going into quadrant 2. And you'll notice it's not going to do the whole thing because there's going to be a pattern that emerges, which is great. So 2 pi over 3 is negative 1/2 root 3 over 2. Negative root 2 over 2. Positive root 2 over 2. Negative root 3 over 2. Positive 1/2. Negative 1, 0. Okay, some of these I'm going to warn you are irritating. However, the good news is once you pick up on the pattern, you only have to do the irritating part once. So it's going to be okay, I promise. Also, I'm going to transfer the values from tangent onto the unit circle. I'm going to put them like next to the coordinates. That's up to you. You do not need to label your unit circle with tangents if you don't want to. I just like having it on there for my purposes. But anyway, okay. So tan is sine over cosine. So in this case, it's 0 over 1 equals 0. Do you see where I'm getting that from? So this divided by this. Okay, next one. This is the most irritating one of all of them. It has to be second. 1/2 divided by root 3 over 2. And I'm going to write it like this because of the room I have. Okay, does anybody remember about keep, change, flip? Okay, so when I divide fractions, I keep the first one, I change it to multiplication, and I flip the second one. So this is going to be 2 over square root 3. So keep, change to multiplication, flip. Are you with me so far? Okay, now what cancels out in this problem? 2's. Okay, and this is where it's going to get irritating. Oh no, your math 2 teacher's face shows up in your brain and goes, you can't leave a root on the bottom. Do you like my voice for your math 2 teacher? What do you have to do to fix that? Yep. Does anybody know the correct terminology? What is that? What is that actually called? It's called rationalizing the denominator. Okay, now over here, I'm just going to start to, and you guys don't need to do this. I'll do this for all of us just to save time. So clearly 0 is approximately 0. Root 3 divided by 3 is 0.577. We're going to use these decimals to graph at the bottom because I don't know if you guys can graph root 3 over 3, but I know you can graph 0.57. Okay, this one's my favorite. Root 2 over 2 divided by root 2 over 2. What's something divided by itself? 1. You don't even need to do any math there. When it's the same thing, it's 1. What's 1 approximately? 1. Okay, now you're going to start to get nervous about this guy because you got this thing again, but it's not that bad. So sine divided by cosine, y divided by x, keep, change, flip. Okay, what cancels? The 2's, and this time I just have root 3 over 1, which does not need to be rationalized. Yay! Okay, and then here's a fun one. One divided by zero is undefined. Let me find root 3 for you real quick. I think it's 1.7. Yeah. Okay. Now we're going to speed up the train and look for patterns because you don't want to do all that math again, do you? Probably not. So root 3 over 2 divided by -1/2. Which problem is this almost exactly like? Looking above. Pi over 3, right? Isn't this almost exactly the same problem? Okay, what's the only difference? Negative, so negative root 3, negative 1.732. We're going to be pattern detectors so that we can be lazy. Pattern detection is good for your brain. Okay. Root 2 over 2 divided by negative root 2 over 2. What's the same thing divided by, wait, what's something divided by its negative self? -1. Positive 1/2 divided by negative root 3 over 2. Okay, which one is this almost exactly like? Pi over 6, right? Those two are almost exactly the same. It's just that one of them's negative. So it's going to be negative root 3 over 3 and negative 0.577. Okay, so you're noticing the table pattern. You're noticing the pattern here. 0 divided by -1 is 0. Okay, now 7 pi over 6. This is -1/2 divided by negative root 3 over 2. Okay, can you guys tell that it's almost exactly the same as 5 pi over 6's problem? Okay, however, there's two negatives. What's a negative divided by a negative? Positive. So I just have to steal that answer and make it positive. Okay, now we're going to answer these questions. Where is tangent greater than 0 and where is it less than 0? And the answers to this are quadrants. Okay, so let's look up here. This quadrant is these first guys up to this. So from here to here. Is tangent positive or negative? Positive. And why does that make sense as far as my little picture goes? A positive divided by a positive is positive. Okay, so we're going to come back up here and put tan. Sine, cosine, and tangent are all positive in quadrant 1. Okay, now let's use our logic. What's a positive divided by a negative? Negative. So in quadrant 2, tan will be negative, and that makes sense because these were all quadrant 2 entries. Okay, what about quadrant 3? What's a negative divided by a negative? It's kind of counterintuitive because you think everything should be negative, but you have to remember tangent is division. Oh no, I didn't leave very much room over here. I'm gonna have to draw my circle. Okay, or oh, I know my shapes, I swear. Okay, what's a negative divided by a positive? Negative, so tan is negative in quadrant 4. When will those come in handy for you? They're going to come in handy for you on your Pythagorean identity problems because soon I'm going to ask you to also find tangent. Okay. Now we're going to come back here. So tangent is positive in quadrants 1 and 3. And tangent is negative in quadrants 2 and 4. You can write those in the regular numbers if you don't want to use the Roman numerals. Where is tangent positive and negative 1? Where is tangent positive and negative 1? Thinking about the fact that when you divide something by itself, it makes 1. It would be this spot, right? Wouldn't this make positive 1, guys? I'm going to put my tangents on the outside. Again, you don't have to label your unit circle if you don't want to. What about this spot here? This spot would be negative 1. This spot, positive or negative? Positive 1. And this spot here, negative 1. Okay. So we have 4 spots where it's either positive or negative 1. It's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Somebody tell me like a rule for that. Yes. Or I was going to say all of the odd pies over 4s is this. Mine was super scientific. Okay, where is tangent 0? Where is tangent 0? It's 2 spots. 0 and pi. Tangent is 0 at 0 and pi. Where is tangent undefined? Yeah, so here and here. So that's pi over 2 and 3 pi over 2. And when it says, how do you see this on the graph? I want you to hold that thought for a second. Okay, go back to your unit circle. We're just going to finish up the unit circle and then we're going to graph tangent. And then I think we're done. It's crazy. Okay, anyway. All right, so go back here. We're going to label the exact values of tan. I'm just going to put them outside of the coordinate. You can do whatever you want. This is root 3 over 3. I got the 1. Root 3. Okay, my first quadrant's all set. Negative root 3. Negative root 3 over 3. Okay, so this one has to be positive root 3 over 3. Positive 1. Positive root 3. negative root 3 negative root 3 over 3. One more thing before we leave the unit circle. By the way, after this next 10 seconds, the unit circle will be completely completed, like checked off, perfectly done, all the way done. The last thing I want to do is come back up here and say tan theta equals y over x. Just so that you have a reference to remind you of what happened to get tangent. Okay, unit circle's completely done now. This page is all for your reference. The last thing we have to do is graph the tangent, a function at the bottom, which is my favorite part of the day. So, okay, here we go. We're going to graph this off of the approximate values over here. So it says this is the angle and this is the y value of the coordinate. So I want you guys to look at the first thing and the last thing at the table for the graphing. So this is 0, 0. So come down to your graph and make a dot at 0, 0. Okay, the next dot is at pi over 6, 0.577. So we're going to go pi over 6, like 0.6-ish, just like right there. Are you guys seeing where I'm getting the values from? It's the very first line in the table and the very last line in the table. Okay, pi over 4 is 1. Pi over 4, by the way, is located in between those two, so it's not labeled, but it's between these two. You can tell that from your unit circle too. Pi over 3 is 1.732. And pi over 2 is undefined. What I want you guys to do on the undefined spots is I want you to draw a vertical asymptote with a dashed line. And then come back to this spot and answer this by saying, how do you see this on the graph? Vertical asymptotes. Okay, let's graph quadrant 2 and see what happens. So 2 pi over 3 is negative 1.732. Like there-ish. 3 pi over 4 is negative 1, and that's the spot in between 2 pi over 3 and 5 pi over 6. 5 pi over 6 is negative 0.577, so negative 0.66-ish. Pi is 0. And 7 pi over 6 is 0.577. Okay, and what you're supposed to do from this moment is you're supposed to go back here to this one and start copying this pattern. So, okay, so I have this dot. I have this dot. So the next dot must be here. And the next dot must be here. And then I have vertical asymptote. And now I'm hoping you're thinking to yourself, what the heck is this thing? It's really strange. Let me graph it for you in the correct mode. Hold on, let me fix my mode. It looks like repeating cubic functions with asymptotes between. So you can kind of see what's going to happen. So it's going to go like this. And then it just keeps repeating itself. Isn't that weird? Um, anyway, again, I'm never going to ask you to graph tangent on a test or quiz in this class, but I do think it's good to know what it looks like. And just in case, you want to sound smart, you know what tangent is. But we will use tangent on our Pythagorean identity problems. So the one thing you need to memorize kind of is tangent is y over x or sine over cosine. If you can memorize that, then you'll be set. I do not need you to keep going on the tangent graph. We're good. He's done, unless you want to, because satisfying. Okay, can you guys look at the stamp sheet real quick just to confirm the homework situation? So we did not have weekend homework. I think everyone should have quiz here and nothing here, which I can stamp at any time. 84 is just what we just did. So the homework is 88, 89, 91, 92, 94. And you might be irritated that there's 5 problems instead of 4. But if you look down here on March 6th, there's only 3. There's your trade-off. So anyway, I think that's everything.